So I want to just to kind of frame some of why we might be doing well around the guiding principles for school mathematics from the NCTM. And I'm not going through all of them. I'm just going to focus on the top two, in fact, just to kind of situate and frame some of the work that we do. I want to talk about access and equity, and I want to talk about curriculum, because a lot of the focus of this is about curriculum and the kind of work that we do in this province around curriculum. So one of the principles from NCTM says access and equity, and that means that every single student has a right to a high-quality program. And I think particularly when we're talking about students who might be struggling learners, I think it's important that we recognize that they need just as high a quality program as all of the other students. So when I think about what equity means, to me, it means that all students have a right, like every student, to engage in rich mathematical activity. That's not just for our gifted kids, it's not just for our students who are in the academic program. It's actually all students have that right, because we know from the research that that's how they learn mathematics. And all students have a right to have opportunities to develop their own strategies for solving problems. Some of the research that we've done shows that actually it's particularly important for struggling learners to be able to develop their own strategies so that they can connect some of the other ideas to their own understandings. When all we do is kind of pretend it's a blank slate and we tell them how to solve a problem, they generally do not connect. They need to try the problem and develop their own strategies first. They need time to investigate mathematical ideas, and they have a right to develop conceptual understanding as well. It's not just 50 questions and just practice these. And they also need to feel valued as mathematical thinkers. We're all mathematical thinkers. I know all of us in the room probably see ourselves as mathematical thinkers, but not the entire world necessarily sees themselves as mathematical thinkers, but we all are mathematical thinkers. It often gets wiped away when we go to school. I think about this researcher, Paul Cobb, who worked with a little girl. She was adding 16 and 9, and she had been taught to carry the 1 that day. And she kept getting the wrong answer. She kept getting 100 and something because she didn't know what the heck to do with the carry the 1 thing. And he said to her, okay, so if you're at home and you have 16 cookies and you have 9 cookies, so how many would that be? And she said, well, that's easy, that's 25, but that's math at home, that's not math at school. That's what we do to kids, though. We wipe away their own sense of mathematics and their own sense that they know how to do math, and we show them rules and procedures, and they don't connect whatsoever. But all students have the right to develop their own strategies and make sense out of the mathematics, and to see themselves as a mathematical being, because we know that they are. So to me, that's what equity means, and I think that's particularly important to think about as we think about grade 9 applied. Another one, guiding principle, is curriculum. And a lot of the work we do, particularly this morning, is around the math curriculum in Ontario. So this is a principle that an excellent math program includes a curriculum that develops important mathematics. Not stuff that's easy to measure, but important mathematics, along coherent learning progressions. So recognizing how kids learn and connect ideas. And a learning progression does not necessarily mean it has to be linear. Ideas are networked. So just because there's what we would consider a missing link, find out something else the kid knows so that you can connect it to that. And they need to be able to make connections between mathematics in everyday life and the mathematics that they understand. So I know, because I've done some work with the Ontario curriculum and done some background research reports even before 2005 curriculum, that our curriculum is actually built in consultation with many different people. Some of my colleagues in the US say, what? You mean math education researchers are involved in writing the curriculum? And I go, well, yeah, of course. Like, they know what the research is saying, because policymakers in many of the states actually ignore the math ed researchers. Doesn't make any sense. But here they're consulted. And teachers are consulted, and higher ed math profs are consulted, and parents are consulted. And so whenever the ministry does a curriculum review, they first find out, what's the research saying? What are some new things that we've learned? And they also do a study as to, so how does this align with the curriculum of other jurisdictions? particularly high-performing countries. Doesn't make sense to look at the low-performing countries. Let's see what the best countries are doing, and let's compare our curriculum. And for instance, in the 2005, the addition of the mathematical processes probably came about because of a comparison of our curriculum with many of the other countries, high-performing countries, that highlighted the mathematical processes or practices or competencies. They're called very different things in different countries. So our curriculum evolves in that sort of way. It also includes, as you know, math content and processes. It promotes a variety of mathematical activity, actions. It really helps to describe what math teaching and learning should look like. And I consider it a starting point if I design a lesson. And some of you I know, I recognize, were my teacher candidates and would testify that, yes, if you do a lesson plan for Chris, the first thing in her rubric is, how well does it address the curriculum expectations that it's supposed to be addressing? That's the first thing I look at, not just the content, but actually the verbs as well. So we're going to think about, so what does curriculum look like as it moves into classrooms? So I see illustrate, interpret, manipulate, solve, think, apply, manipulate, extrapolate, investigate, describe, solve, express, simplify, connect, determine. I might have done that. Illustrate. Got another one I haven't said. Pose. Pose problems, I think it means, right? Not just pose. Like, they like to do that too. Interpret. Compare. Conjecture. Wow, isn't that amazing? So that is what I should see in a grade 9 applied mathematics class. Those are the verbs. These are just a few of what you said. So if I think about what I should be seeing in a grade 9 applied mathematics class, these are the actions that, by the way, students should be doing. So one thing that that curriculum says is that students will. Those verbs are the actions of students, not the actions of teachers. So it's not that teachers will describe, teachers will explain, teachers will post. No, it's students will. To me, that's the key word here. Those are the mathematical actions that I should see students actually doing in a mathematics class. I do a lot of work with principals, and I recognize some of the principals in the room. And when they say, what are the look-fors in a math class, to me, those are the look-fors. Those are the kinds of things that I should see in a math class happening, because those are the verbs in the curriculum. And all too often, we only pay attention to the nouns. So the verbs are also important.